I am a blue box. This. And share this. So if you go to Canvas right now, so here I am. I am logged in as a student, logged into student view. So my name is Mr. Student, first name test. If I go to grades, so you can do this too. Everybody who's a student in my class, here's all your grades, blah, blah, blah. Mr. Test students really, really, really suck in here. But somehow, so if you go all the way to the bottom, see how this is zeros? Because I don't let Canvas do anything with my grades because Canvas sucks when it comes to calculating grades. So screw you, Canvas. I have put in right here, it says average grade of all homework turned in and okay, average grade of no homework turned in, overall average not counting homework. Everybody with me? So you can all find that right at the bottom of the grades. Bam, 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 bam. Bam, 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 bam. Bam, bam, bam. You guys all right out there? So take a look. Also, your midterms graded. Sorry, go ahead.
I was just going to say I was all right. Make sure that.
Sorry?
I was just going to, you asked if we were all right. So I was going to say I was all right to make sure you knew that I was paying attention.
Thank you so much. That does help me because I could see one of you right now. So I don't know what the rest of you guys are doing. Yeah, you got the Jeff show in the background and you go do something else. I understand. Jeff show is a boring show. All right, so let me know. I've carved out a little bit of time here at the beginning for questions about grades, questions about the midterm, questions from any homework stuff. Hopefully this weekend I catch up on grading, quiz corrections, and all that kind of stuff, and homework. Okay.
So it's cool if we ask questions about stuff on the midterm?
Of course.
Cool. So I have a question.
Yeah.
So for, let's see if I can find it. Number 7 on it. I don't know if we all have the same midterm, but it's like the 12 million times the point.
Yes.
Yeah. Okay. So I came to the conclusion that the decimal was like 3 significant digits. And then when I did the multiplication, I didn't know in which direction to start, like that it would count that it would be 3. Because I put 0.554, but apparently that wasn't correct.
Oh, well, you were close. That's all I'll say. Just what's the next digit after 4 in your original answer?
To the right or to the left?
No. So the point is you're basically rounding. And how do you tell which place to round to is based on the number of sig digs it needs, right?
Oh,
so you just didn't round correctly. That's all. So a few people did that same thing.
Oh, okay.
All right. Let me see. I lost you guys again. There you guys are. Okay. Anything else from there, everybody? I mean, overall, it went pretty well.
Someone typed in the chat.
Sorry?
Someone typed in the chat.
Oh, yes, you can. The only thing you cannot correct is the appropriately named final. Right? So I always have somebody, even if I say that several times, you cannot correct the final. The final is the end. I'll still have somebody write to me after the final and say, can I just do corrections of the final? No. Right? That's the one thing you can't correct. You can correct every single thing once, except for the final. Is everybody with me? So corrections on the midterm work just like corrections on the quizzes, the exact same idea. Okay.
I have another one if no one has one at the moment.
Yeah.
Number 10, multiplying scientific notation, two things in scientific notation. I thought you
wait. Look at number 10. What's the operation in the middle?
Multiplication, is it not? Or I'll have to go through the actual midterm. I'm looking at the corrections.
Oh, okay. You have to look at the midterm to look at the question. Yeah. Doesn't say times.
Just taking a second to load. Oh, right. Huh.
Okay. Yeah, so a few people multiplied them, but it's got a plus sign there, so that's a giveaway. Is that all right? So
Yeah.
the point there was the fact that they don't have the same exponents. So you can't just say it's 5. You know, you can't add the 2 and the 3 because they're not in the same place. Yeah, okay. So now you got to figure out how to do that. Okay, I like it. Anybody else? You guys all right? I mean, the average was in 83, so I was very happy. Of course, that means some people got quite below that. Some, I think the highest grade was a 92. No, 90. Oops, shit. I'm looking at the wrong thing. 94. Yeah, 94 was the highest. A couple people got a 94. And you can make corrections. So, okay. All right. Not seeing any other questions.
Is this stuff gonna be on the final too?
Yes, totally.
Okay, cool.
Which is one reason. So last semester, I didn't give a midterm. I just gave a ton of quizzes and then a final. And the evil thing about that is then it's forever since you did the first stuff, right? So I like the idea of throwing a midterm in there to keep the earlier stuff a little bit fresher as you get closer to the final exam. So that's my purpose. Also, the midterm originally was supposed to be on camera, but you know, oh, things happen. And I just wanted to be greedy and carve time out. And I also wanted to give you guys a chance to, you know, witness history as you live through it. So many firsts in this new administration, independent of how you feel about them. Anyway, all right.
I have yet another question.
John.
So for the point system on the voting, I thought that like in whatever place that it was, we just assigned our own point value and then moved from there. Like in first place, we get 5 points. Second, we get 3 points. Third, we get 1. Fourth, if there was fourth, 0, and then that would dictate who would win the points when it like.
Well,
like
the main way to do it is to give 1 point to the last place and then go up by 1 from there. If you used a different, since I didn't say board account, I guess I could take a different answer, but let me see. I'd have to look at yours specifically. I don't know if you showed me enough work or something, because I don't remember anybody doing what you're saying right now. So if you did that,
it's probably because I didn't like write out the list, but I had put like A got 5 plus 1 plus 1.
That explains that. Okay, but the other problem you have is you're assuming that it only happened once. How many first place votes did A get? It didn't happen one time.
So it happened. Oh, okay, so you'd have to multiply it by the number of votes?
Yeah. Now, if you would have done that, I might have caught on to what you were doing, but yeah. Because for each first place vote, anybody would get 5 points in your system, right?
Right.
And he didn't just get 1 first place vote.
Oh, I'm gonna have to go back and do a lot of homework corrections then.
Okay, probably. I mean, yeah. Otherwise, it's not really fair. I mean, right? If I got 80 first place votes and this other guy got 1, we don't both get the same points. I mean, that would be mean. Anybody else? You guys doing okay? I keep saying that because I used to be able to just look at you and tell if you were doing okay. What's up, Ian? Are you going to tell me you're okay again?
No, I got number 12A totally wrong, and I was relatively confident on that one. And it's just a Venn diagram question. But can you show me what I was supposed to do?
Let's see, 12A for you. Which version did you have? Here we go. Oh, okay. So I think your version, yeah. People who got arrested, people who broke. Yeah. So doesn't your first statement say, was it an if-then statement? Let me see, I have to look up yours. If you break curfew, then you get arrested, right?
Yeah.
All right. Can you find somebody in the broke curfew that did not get arrested? Yes, you can, the way that you've drawn it. So that can't be the way to draw that. So you just got the two
Wait,
circles
what?
backwards. So if you break curfew, then you get arrested, correct?
Oh, I see.
Yeah, so you got those backwards because I can see somebody who broke curfew but did not get arrested the way you drew it. So you don't match the premise.
Okay, I understand.
Cool.
That's a simple enough fix.
Yeah. And it's a really understandable mistake to make, but you just got to take a second when you draw something, step back and go, does that capture the idea?
Yeah, I got you.
Cool. All right, guys. So nobody failed the midterm, which is very nice, right? There are a few people that got C's, but that's the lowest grade anybody got. So that was nice. That was nice. I like that. Okay, and you can make corrections, so that's really nice. All right, so I'm going to slowly start to move on. Let me know if you have a question. Let me see, where am I at? I think last time we just did a few definitions out of chapter 5, right? And let me double check something too before we jump back into statistics. Yeah, here we go. Just to remind you guys, well, when is our next quiz? Anybody know?
Is it the 24th?
The 25th, I think, or 24th?
25th. Yeah, 25th. 24th would be really evil, man. Yeah, on Monday, our next quiz happens, and that's on chapter 4. That's on the finances chapter, the really exciting interest stuff. All right, so I'm going to try to get all that graded over the weekend, so you have that to look at. And then the very next day, we have another quiz, right? Because we're all crazy. That's on chapter 5. And then the next thing to happen after that is the final exam, of course. So there will be chapter 6, chapter 7, chapter 8, chapter 11 that won't get their own quizzes because there's not enough time to shove that in there. So, okay. Okay, moving on. Let me see.
Excuse me, Professor. Good
Yes.
morning.
Hey, good morning. What's up?
Well, good morning. Will chapter 6 and 7 be on the final?
Everything
You
will be.
said they won't have a quiz, right?
They won't have a quiz.
Everything will be okay.
Everything will be on the final, yeah. It's just the nature of a 4-week course. It's just no way to, yeah. I think you're okay. You don't want me to try to shove another quiz in there, right? I don't think anybody does. Like no magic tricks with the quizzes, Jeff. Okay. All right, here we go. Let's get back into it. So I think we left off, we talked about population sample, and we talked about parameter statistic. So can somebody tell me which two things go together between population sample and parameter, statistic.
Parameter, population, sample, and statistic, was it?
Yes. So that's number one. And that's too good to believe. Holy shit. Can you believe this shit? You're like, good job, math people. You finally made something. Parameter, population. I mean, that's beautiful. The next level is population and statistics are groups. They're just groups of things or people. Parameter and statistic are numerical descriptions of their associated group, right? So a parameter is normally something like an average or a percentage. So let me say this, get ready. Is this a parameter or a statistic? 78% of all Americans enjoy soup. 78% of all Americans enjoy soup. Is that a parameter or a statistic? Remember, be careful. Am I describing a population or am I describing a sample when I say 78% of all Americans enjoy soup?
A sample.
What's the sample?
That would be the 78 Americans, wouldn't it?
Ah, okay. No. Okay, I really want you guys. 78% is the numerical description, right? What group am I describing when I say 78% of all Americans enjoy soup? What group am I talking about? What group am I describing?
You're describing a percentage of the population.
No.
Americans.
Which Americans? Which Americans?
Well, like
The ones that drink soup? Or
No,
eat soup?
all Americans.
Nope. All Americans. There we go. There we go. If I say 78% of all Americans enjoy soup, I'm not just talking about the ones that enjoy soup. I'm talking about all of them. That's how I got 78%. If I only looked at the ones that enjoy soup, wouldn't that be 100%? 100% of Americans that enjoy soup enjoy soup. Ooh, good job. Make an article out of that. I'm sorry. I just really want you guys to see that I can't create a percentage without considering the whole denominator. So what's the denominator about here? All Americans. That is what makes it a parameter, is because it's describing a population. Now, if I said 78% of the 300 Americans I surveyed enjoy soup, what is that one? "78% of the 300 Americans I surveyed enjoy soup."
Isn't that a parameter then? Or no?
Nope.
So that one's a statistic.
Yes, because if I survey 300 Americans, is that a sample or a population?
Wouldn't that be a sample?
Yes. Isn't that one of the most basic ways to get a sample, is to survey people? Send a survey out or stand on street corners or something, right? I really want you guys to get this. So what's a key word that doesn't necessarily have to show up, but when it does, it's over, is the word all. If I say the average age of all people in Wyoming is 29, which is probably false, but oh well. That would be an example of a parameter because I'm talking about all people in Wyoming, right? If I said 30%, I'm sorry, the average age of people in people that, I don't know, the average age of 80 people we survey in Florida is something, I mean, that's obviously a statistic now, right? Now I'm talking about a sample. That's how you tell, is this numerical description a parameter? Well, what's it talking about? What's it describing? 78% of all Americans enjoy soup, parameter. 78% of a sample of 300 or a survey of 300 or something, Americans enjoy soup, statistic. Okay, how are you doing out there, you guys? That's all it is. It's just, don't look at the number. What group is it describing? Okay, I like it. Hey, Mikey. Okay, okay. All right, so now. Yes, sorry.
Just give one more example, please, just briefly again.
All
I'm getting
right.
it. But if you,
If I said, the median income of all Ecuadorians is $50,000, right? Translated. You guys with me? The median income of all Ecuadorians is $50,000. Does the 50,000 median, is that a statistic or a parameter?
Parameter.
Parameter. We might not even know what the word median means. I'm hoping that you guys have, some of you guys at least have heard the word median before. But it's just a numerical description. It's a 50,000 is the median. That's a numerical description. All Ecuadorians, that's a population. So it's a parameter then. If I said the median income, now you know the answer is going to be statistic, but if I say the median income of the 928 Ecuadorians that returned the survey was $50,000, now that is a
Statistic.
I like it. Nobody wanted to answer. You're like, you already said the answer, Jeff. Yeah. Okay. Is that all right, you guys? Does that make sense? So again, it'll almost always have the word all, but don't. I mean, another way I could say it is, like I just said. I think I said the median of every Ecuadorian. Okay, that's another name for all, but I mean it's the same idea. Okay. Okay. How's that, everybody? You guys all right?
so when it's the whole population, it's the parameter. And when it's just a certain amount, it's a statistic.
When it's a smaller subset of a bigger group, right?
Not the, okay, smaller subset.
When I say,
Total, smaller subset, okay.
yeah, if I say all people from, what do you call Wyoming people? Wyomingites? Wyoming?
I don't know.
All right, anyway, sorry. So
I laugh because I had cousins in Wyoming. They used to snowbird here and now they all live here.
all right. I'm not even sure.
And then the sample,
Yeah, so if I said all Wyoming people eat cheese or eat 5 pounds of cheese on average a day, that holy shit, that would be a parameter. But if I said the average amount of cheese was 5 pounds for the 30 Wyoming people, Wyomingites that showed up to answer our question, that would be, that's a sample we took of a larger population, right? So it should be really clear if it's a population. It's going to have to be all, every, something like that, right? I'm not leaving anybody out of this group. Sample's going to be 38 of these people or 500 surveyed these people.
oh, okay.
Up to everybody. Yeah. Okay. That's the distinction. Okay.
Great,
So what
thank
does
you.
statistics try to do then? Why would we take a sample instead of talk to everybody?
To try to get an idea of the average without having to talk to every single person.
Yeah, because is it possible to talk to every single person? Very often, no, it isn't. So statistics tries to estimate a parameter based on a statistic. That's one of the main things that a huge group of statistics does. It's not the only thing statistics does, but so we take a sample, so then we can estimate something about the whole population, which we couldn't even talk to anyway. It's out of our control. We can't do it, right? Well, let's talk to 330 million people. Let's go. No, it's not gonna, no. Okay, all right. So the immediate next thing that makes sense to talk about is how the shit do we pick samples? Is there only one way to pick a sample? Is there other ways to pick a sample? Are there bad ways to pick samples? So let's discuss ways to pick a sample. Cooperate. Cooperate. Okay. Cooperate. Sorry. Any Doctor Who fans out there? No. All right, everybody just get out of the way. My living room is not the classroom. Okay. So one of the ways to pick a sample is kind of like the baseline. And it's the main thing we're always trying to get, and it's actually called a simple random sample. That is the gold standard. And it's sort of like, it is its own method, but it's sort of like what every method is trying to achieve. So a simple random sample is technically this: every possible group. Let me see. How do I say this? Every possible, group from the population has an equal chance to be picked. So if I had a method to take a sample from Grossmont and I wanted to take a sample of 20 people, in order to be a simple random sample, every possible group of 20 people should have an equal chance of being picked. Now think about that. Wouldn't that eliminate possible biases? Oh shit, we're going to focus on biases later. What the hell is a bias? How can you pick a sample that would be completely biased? If you're like, let me take a sample of people to see what they think about me. How could I make that really biased?
Asking your friends.
Yeah, ask my friends, right? Although some of them would then, you're a piece of shit, Jeff. Shut up. No. Does that make sense? And if I did that, if I only spoke to my friends and I was saying, like 98% of Americans like me, did every American have an equal chance to get into that sample?
Probably not.
No, of course not, because I don't know every American, right? Okay. That's the most direct way bias shows up, is if I somehow control who gets in my sample based on something that could skew the results, right, guys? Even if it's not even something like that, even if I, let me see how my students feel about me, but I'm only going to take people from an afternoon class instead of all my classes, right? Maybe the morning class doesn't like me as much because they just don't like anything. It's at 7 in the morning or something, right? I hate that guy. I hate everything. I hate the sky. I hate my bed. I hate everything. I love my bed, actually.
You have a 7 o'clock. You have a 7 o'clock class?
I have had 7 a.m. classes before, and
You just roll out of bed and just turn on your laptop.
this is back in the day when we were in these things called classrooms.
Oh, what's that? Tell me about it.
Classrooms. All right, sorry. Stay with me. Sorry. I'm always like, stay with me, focus, and I'm the one derailing everything.
Professor, have you been drinking your Mr. drink?
Oh yeah, it's here. It's ready. All right, so I can get even more whatever I am. Now, so this is the gold standard. So a method that would be only this would be like putting everybody's name in a hat and picking 5 of those to make a sample. Are you guys with me? Would everybody have an equal chance? Would every group of people have an equal chance to be picked? Yes. Does that make sense? All right. Now, let me put a little side note. I don't think the book really makes a big deal out of this. There is something called just a random sample. And the difference between a simple random sample and a random sample is this one, every person or thing in the population has an equal chance. All right, this is a very subtle difference. Here, every group has an equal chance. Here, every element, every person or thing itself has an equal chance. This is the weaker one, believe it or not. But this is pretty much the standard that we can normally attain for sure. This is the gold standard. Okay, let me stop for a minute. I don't know if you guys are with me or not. It's a very subtle. So here, every group has an equal chance. Here, every individual has an equal chance. This one is the stronger one. Okay. I'm going to point this out as we go through the other methods.
I'm sorry, which one is the stronger one?
This one,
The individual or
the group. Yeah. That doesn't mean that this one sucks. This one is completely fine. If you can attain this, I will trust your results. But this is kind of like the main bad boy. All right, now let's get into, so this is just put a bunch of names in a hat and pick them out, right? No real method to it. And we don't always want to do this. So let's talk about some more specific methods of how to pick a sample. So I'm going to erase all this. All right, here we go. So now some more specific things. There's one called, let's go ahead and do this one, get it out the way. Systematic sampling. Systematic, automatic. Systematic. So if I wanted to pick a sample systematically, the main phrase that goes along with this is every nth. All right, Joe, what the shit does that mean? So like, example, take the temperature every 10 minutes, right? The end collection of numbers would be a systematic sampling of data. Or I could do like, another example is a cop stops every 6th car. All right, that's systematic. Okay, easy. There's a system to it. Every nth is the main idea of systematic sampling. Okay, like if I had a list of all the students at Grossmont and I started, and the thing about systematic, just to make sure that I start at a random first place. What do I mean by that? So if I had a list of all the students at Grossmont and I just kind of, I roll a Dungeons and Dragons die or something, and I start at the 11th person, and then I take every 5th person after that. Can you tell me this? Did everybody have an equal chance to get into the sample if I do that?
It'd be no, wouldn't it? Because there are people in between that are being skipped.
So here, now listen. All right, John, I love it. What you just said is what other people are thinking. And let me tell you really quickly how that's not the right way to think about this. Anytime I take a sample, I'm going to leave people out. That's the whole idea of a sample, right? Before I did anything, would this process allow for anybody to be picked? Would there be anybody that could not be picked on my list? Because if I roll a die to pick the first, sorry, go ahead. Nancy?
I
Go ahead.
think so, because you started with the random, so more people had an opportunity to be picked.
Every single person on the list could be picked because I could roll a 1 on that die. Start at the first person, take every 5th person. I could start at the second person. I could start at the third person. You guys get it? So this is a good method. It ends up getting a random sample. It doesn't end up getting a simple random sample. So that's what I want you guys to realize, the distinction. Could the first 8 people on the list be in the sample? No, not systematically, because now I'm skipping. I really want you guys to get this. Does every individual have a chance to get into the sample? Yes. Because I start at a random place and then I pick every 5th person. There's nobody you could identify that would have no chance to get into the sample. Could the first person get in the sample?
Yes.
Could the second person get in the sample? Yes. Could the third person? Yes. Could the 4th person? Yes. All the way to the 20th person, I have a 20-sided die. And then the 21st person could get in the sample because if I start at the 16th person, 5 later is 21. And then the 22nd person can get in the sample and holy shit, right? You guys, you doing all
So
right?
what
Danielle?
is
You
this
look-
called?
No, sorry?
What is this called? If you start off with random and then you go to the
That is systematic. That is the process.
systematic sampling, okay.
That is systematic. So if I have a list of people, I have a 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, 21st, 22nd, blah, 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 blah. Right? Let's just say I have a normal die. I'll roll a normal die, and that tells me who to start with. Because, so I roll a die and I get 1. And then I'm going to take every 5th person. So I take the first person, 1, 2, 3, 4, 5. The 6th person, 1, 2, 3, 4, 5. The 11th person, I would make a sample. Does that mean I would never have picked the second one? No, because when I rolled a die, I could have rolled a 2. So don't say to yourself, well, it didn't pick 2, so it's not random. No. I'm going to skip people. That's a sample. That's what a sample does. It's trying to keep me from having to talk to everybody. It's just that were there people eliminated from the beginning? No, nobody was eliminated from the beginning. I could have rolled a 2, and then I would have picked 7 and 12. I could have rolled a 3, and then I would have picked 8 and 13. I could have rolled a 4. I could have rolled a 5. I could have rolled a 6.
Ask a question.
Would have been impossible to pick. Go ahead.
So are 2 and 3 just as strong as one another as far as sampling goes? Because I know
All right.
number 1's the gold standard, and the reason why like the systematic sampling isn't as strong is because you don't know if you got somebody from every group. Is that correct?
Well, now we know this for sure. Could these people be all in the sample based on the way I'm doing things? Could all of these people be in my sample?
No.
No, there's no way in hell, because the whole idea of systematic is I skip a bunch and then I skip a bunch. So this is not simple random. This is not the absolute gold standard.
Right.
This is just random, which is fine. That's fine. We'll take random because every single person had a chance to be picked.
So it's just as strong as the random sampling. It's
Yes,
on the
it's
same.
the random sampling strength. I love it.
Okay, thank you.
Which is good, which is fine. You have to have that level in order to write your journal article and have anybody pay any attention to you. Okay, maybe. I really want you guys to get this. If the way I did systematic sampling was I always started at the first one and then went so many, then I could argue that's not random, because I would always skip some people, the same people. They would never have a chance with me. That's why there's that first, you start at a random place that makes sure that everybody had a chance to be picked. All right. So the main idea with system The main idea with systematic is every nth. That's the most important thing. Why is it an okay method? Because it does end up being a random sample. Everybody, every single person or thing has a chance to be picked. So there's no systemic bias there. There's no, okay, maybe. I don't want the, I'm getting a little more technical than we have to be. So what's the main thing with systematic? Can you identify it when you see it? If I said, what kind of sampling is this? I take every 7th bird I see and I count the number of chirps or something. I mean, so that would be systematic because it's every nth, every 7th. That's the level of question I'm going to throw at you. Why is systematic a good sampling method? Because it does allow for everybody to have a chance. It would then be representative of the population. If I try to use a certain sampling method to say something about all Americans, and the sampling method only allowed people in that live in Delaware, is that a representative good way to pick? No. So if that was the only way to get in the sample was to be in Delaware, then I can't say shit about all Americans because it's not representative. Not every American had an equal chance. Okay, maybe. So I hear this a lot. Okay, all right, I don't want to get controversial, but I hear a lot of people, unfortunately I run into a lot of people, not in real life anymore because of COVID, and we talk about COVID, and they say, well, everybody I know, I don't know if that's the way they sound. I am a redneck myself. I'm a non-practicing redneck. I was born in Savannah, Georgia. But they say something like, well, everybody I know, none of them has passed away from COVID. So it's all a lie. Now we know that's a fallacy, but it's also a biased sample, right? Just because everybody you know, nobody's died from COVID doesn't mean the whole thing's a hoax. So that's a fallacy. That's a sampling error. Are you guys kind of with me? Okay, there's definitely bias in that sample. I love it. What's up, John?
So when we're looking, like when we're doing questions for this section, either in homework or test or whatever, the thing that we're looking for if we think it's systematic, or systemic, excuse me, is not like, oh, it started at a random place, but it's just that, oh, I go from this to this every whatever.
Every nth.
Nth, yeah, okay.
Like it could be every minute. Could be every hour. It could be every 5 feet. I take a sample of grass, right? Every something. Okay, I like it. Now, once we get all of the methods down, you can start to see how to tell between them. That's what you're going to have to be able to do. Which method is this? Okay, so that's systematic. Let's do the next two. Let me see, let me keep myself straight. Yeah, let's do those next two together because they are connected to each other. And the book doesn't even talk about this one, but I'm going to talk about this one because it exists and it's important. And why the shit did you leave it out, book? All right, these sound exciting. Stratified method of sample collecting and cluster method of sample collecting. So they both start with the same first step, which is why everybody gets these poor things confused. They both start, the first step is to break the population, Jeff, into groups. They both have the same first step. Why did they give you so little room, cluster? Oh well. Break pop into groups. Hey pop, what? So it could be like a high school, freshmen, sophomores, juniors, seniors. You guys with me? It could be political parties, Democrat, Republican, Libertarian, Independent, and of course there's many more after that. You guys with me? So it's like either your population is already or zip codes. Could be zip codes. Whatever way to break your population up into groups. So you can start to see why you would want to use these kind of methods. Stratified, you would definitely want to use it so that, get out of there, every group is represented. So if you're trying to say something about high school and you want to take a sample, you probably want a sample from each grade level because they all have kind of different concerns and you want all those addressed as everybody. Does that make sense? Or political parties or whatever. States, if you want to say something about America, you probably want to break it up into states and take some people. So that's what Stratified would do, is its second step would say, take a few things from each group. And that's your sample. So maybe you could take 4 people from each of these, and that would make your sample. So its little saying is sum from all. Does that make any sense? I take sum from all groups. Sounds a little bit Three Musketeers-ish. No? Does anybody get that? No. Some from all and all from some. So cluster would say, that's nice. In fact, what's a cluster cereal? What does it mean? When you see a cereal, it's got the word cluster in it. What are you going to see when you pour it in your bowls? Anybody eat those kind of cereals? Aren't you going to see like clusters? So when you put your spoon in, don't you get the whole damn thing? Unless you chop it up. You guys semi with me? So cluster does exactly what this sounds like. It's going to randomly pick. So it's going to randomly pick 2 and take everybody from those and nobody from these. And that would be my sample. Now, this is the one where people get confused. Are either one of these not on the level of random sample? So let's look at stratified first. So remember, there are many people, think of this as classrooms, those mythical things that were in the before times. If I took a sample from each, don't I leave some out from each room? But was there anybody that did not have a chance to be picked?
No.
If I randomly select 4 people from each room, every single person had a chance to be picked. All right, so stratified is at the level of random. It is not simple random because could all of the people in this room be in the sample? No, because I'm only taking some of them to be in my sample. So it's not at the level of simple random, but it is at the level of random, which is good. That's fine. Cluster. What about cluster? This is one where people think it's not random. I'm going to give it away at the beginning. It is random. It is totally. And people are like, what about that guy? He didn't have a chance. No, you're thinking after you picked. Before I pick, if I randomly choose 2 groups, could I have picked that guy?
Yes.
Yes. Cool. Once I pick shit, of course I'm going to leave people out. So it's not fair to look at it once you've picked. Well, you didn't pick Randy. Be quiet. I could have. I could have picked Randy. I just didn't pick his room. Randy. Maybe. So you see, these are very simple, very easy to get confused between the 2 of them. Stratified, pick some from each. In fact, it doesn't start with the word S. The word S. This is good. This is good. This is good. All right. The word S is what I just said. I just said the word S. Okay. It starts with the letter S, and the phrase is sum from all. What do you think this phrase is?
All from some.
All from some. And it does not start with the letter S. So it goes with the one that does not start with the letter S. I'm just trying to show you ways to memorize this because you have to have this memorized. This looks like a football play. Oh, well, it's not. No John Madden. And then, of course, you got to take it. No. Okay. These jokes are just for me. Somebody out there should say, jokes? Are you saying jokes right now? All right. And then there's one final method. one final method. I'm going to erase this stuff here. Oh, by the way, before I leave this, one semester I taught statistics, and when I got to cluster method, somebody, I'll never forget this. I'll never forget. I've got the scene in my head. He was in the front row and he said, cluster is bullshit. And I said, okay, that's kind of a strong. And then come to find out, he had fought in the Iraq War. He had fought in that war. And I don't know, this might be ancient. This is ancient for some of you guys. This might have happened before some of you guys were born. Shit. But we went to Iraq for no really good reason, but we're not going to argue that. Baghdad fell. We took control of Baghdad. And then they sent in groups of people to see the conditions in different neighborhoods in Baghdad. So I actually looked the study up that he talked about. And the mistake they made, now listen to what they did. They broke Baghdad up into territories. And they were going to go in and see what the conditions were like. But this was a civilian group. They weren't military. So they said, man, that area is not safe to go into. So we're not going to go there. Do you guys understand how already it's bullshit? I agree with him. I'm like, yeah, but it's not cluster's fault. The humans did it incorrectly. What are you supposed to do at this level? You're supposed to randomly pick. Did they randomly pick areas to take everybody from? No, they did not. They chose areas not to go to. So those areas had no chance to get in. So their results made it seem better than it really was. I love that example. No, are you guys all right with me? What's happening? Is cluster on the same level of strength? Yes, they're both at the same, at random, but neither one is simple random.
Okay, that's what I was going to ask you, if you can reiterate that about the random and simple random.
So, all right. So these are both random because every individual has the same chance to get into the sample. Why was this not simple random? Because not everybody in this room could be in the sample, correct? There's a group of people that don't have a chance to all be in the sample. Are you guys with me? So that's simple random, is look at every possible group. What about cluster? What if these two people and these two people and these two people and these two people, they like each other a lot. They're like, oh, we're really good friends. Oh, we could have a show like Friends, and oh, it'd be great. And they want to all be together in the sample. Could cluster ever let all of these people into the sample? Shit, no. So there's a group that doesn't have a chance to all be in the sample. That's why it's not simple random. I know that's weird. I'm not going to ask a very detailed question about that because it is weird. But I want you to be aware of how you can analyze a method to tell if it's going to be guarded against biases. And that's the most immediate way we have to kind of measure, is this idea of simple random and random. If you can't even achieve random sample strength, I'm not going to pay attention to your results. Screw it. I'm not going to look at your results because I can't tell. It might be beautiful. It might be beautiful results. You might have just happened to get a great sample, but I don't know. You didn't try to safeguard it. I don't know if this is making any sense. So there are methods. Sorry?
And I just want to reiterate my notes here. So for simple random, that's the gold standard. And I have here that every possible group has to have an equal pick.
Equal chance to get in.
Equal chance. Okay, great, thanks.
Good. And then random is just every individual has an equal chance. And that's actually easier to attain. And these really show you why the individual level is easier to attain. If you pick a certain group of people, you can easily see they have no chance to all get in. But each individual person has an equal chance. Maybe. So hopeful. Okay. Let's talk about the last method, and then we'll take a break. What time is it? Yeah. There's one last method. It's the easiest method, and it's the method that sucks. So it's kind of like, why even talk about it? Just because we have to.
So you just said that every individual has a chance with both stratified and cluster?
Yes.
Okay.
And if you don't believe me, you got to let me know, because you're wrong, and I want to show you why. And I'm not saying that to be mean. It is the truth. So if you don't see how that's quite true, you can ask me during the break or something, or right now if you want to. Okay.
Oh, no, I just want to get it right on the test.
Gotcha. Okay. So the last method is called convenience. You can tell from the name that this is going to suck. Convenience method would be something like standing outside a music store and asking people's opinions about whether there should be an award show or not for music. A convenience, you guys. If I wanted to say something about Grossmont and I used you guys as a sample, that is a convenience sample. Why would you guys be a bad sample, right? I'm not saying you're bad people, but you guys would be a bad sample. It'd be a horrible sample. Great people, bad sample. Why?
Bias?
Bias from what? You're right.
From being people who go to Grossmont?
Well, no. I want to say something about Grossmont people. Why would there be bias from this group? It doesn't even matter what the question is. Yeah, go ahead.
Because what if it were a rival school, even though
No,
they're
no,
sister
no, no,
schools? No.
No. Okay.
In chat? Is it the answer in chat?
Not some people, I love it. I've seen videos where people don't know what the hell random is. I'm so random. Shut up. No, you're not.
Is it maybe because we all are going for similar majors?
There we go. Now we're getting somewhere. Not necessarily, but you're certainly not. For example, if normally when you're taking Math 120, that means you're not really a STEM major, right? So you are going to a certain family of majors more than likely. You're also taking this course during intersession. So do you see the main problem? If I take you guys as my sample, would every Grossmont student have had a chance to show up in my sample? Don't even think that no, because now you didn't pick Sam. Well, Sam could have taken this course, but not if he's a different major. What if he's a math major? He's not going to take this course, right? What if there's no way he could take intersession because he's working too much, right? You guys with me? So if I take you guys as my sample, then automatically it's not good enough. Not everybody had a chance to get into my sample. Lexi, what's up? Lexi, are you good? Lexi. All right, I'm going to mute you. Okay, I'm not sure if you unmuted yourself on purpose. Let me see. Okay, how's everybody doing? So convenience sucks. The word convenience really means you did not try to ensure that everybody in the population had a chance. That's why it's called convenience. Okay, hopefully that's good. All right. Oh yeah, let's take a break. So come back 10:20. Come back at 10:20. Hang around if you got a question right now. Stop the recording. The recording has stopped. I was trying to find, I have found at least one study I want to show you guys here in a bit.
Do you have any printouts, any worksheets for this?
I do.
Oh, great. Thanks.
Sure. We'll do that here in a minute. Let me see. All right. And actually, yeah, I could do this while you guys are doing that. So I do have so let me see. I just made it active on Canvas. Let me show you where it is at. So if you go to Canvas, let me become a student. You go to modules. There's now a new module called, remarkably enough, it's called Unit 5. And there's a section 5A practice sheet. Let me see, have we discussed everything on here? I think so, yes. And actually the funny thing is, you'll notice, you guys see how it was the first quiz I gave my statistics class? Actually deleted a couple of questions from this, that stuff that we don't go over, but this is basically what the first things I teach my stats class is what we're going over right now. So get on Canvas, get on in there, get this section 5A practice sheet, go ahead and get this sucker and start working on it. Start doing it. These are the kind of questions I like to ask on quizzes, you know, if we have a quiz in the future on this, which we do. I don't know why I'm making this face. So go ahead and do this. I guess I can set this up. Share this. There were several people who never went to a room who are going to be counted as absent now. That's a bad thing, kids. You got to be here. All right, so here's this. Who's got this first one? Oh shit, let me do this real quick. I gotta plug in my technology here. My poor laptop can USB. All right, guys, who's got this first one for me?
I'll do it.
I'll do it.
Okay, go ahead.
So for the population, we put factory workers.
Okay.
Yeah. And then for the sample, we put 133 factory workers.
All right, so I like the sample's okay as long as your population is better. If the population was, so
would it be all factory workers
okay,
in
okay.
Brazil?
There we go. Those are the two things that we're missing. If you just say factory workers, I'll say which. If you say factory workers in Brazil, I'll say which ones. So all factory workers in Brazil. Why isn't it just all factory workers? Because it would be really strange if their population was.
That could change your
Sorry?
survey. That could change the survey and the population. And
Well-
you could be taking it from all over the world.
You're thinking of it backwards. So how can I tell it wasn't all factory workers? Because they only had them from Brazil. So their population could not have been all factory workers over the whole world, because it would have been remarkably unlikely to end up with 133 just from Brazil if you were picking from all over the world. Because everybody get this idea. So all factory workers in Brazil, replace the word all with a subgroup, 133 factory workers in Brazil. But since you've said it here, then the sample's okay. So is everybody with me on the first part? Did anybody think that this came into play?
I had it totally wrong.
Oh,
Yes, but I get it.
what'd you
now.
have? Yeah, what's the 7%? Does that have anything to do with picking a sample? How did they figure out the 7%?
That's just the result.
Yeah, so they would have first
Gosh.
had to pick a sample, because then they could talk to them. So don't tell me the sample is 7%. It's like, how in the world could they just randomly pick the 7% that wanted to be a dancer? That's a little weird. So they had to pick the 133 first as a sample, and then they could talk to them. Okay, I know. Is anybody not with me on that? So the 7% in this case is a red herring. I'm evil. I don't care. It is in this case, it would be a statistic, right? because that would describe the survey of 133. It doesn't describe the whole population. So it has nothing to do with what the population was and what the sample was. The 7% is what I figured out from the sample that I picked. So that's a later thing. All right. And then number 2 gets a little more specific. Now, who else? Who's got that one for me? Somebody else. What's the key word here that tells you which one of these it is?
All.
Tubular. All right. So which one is it?
It's a parameter.
Parameter. I love it, because all kind of tells you it is a population they're discussing. I like it. And I would agree with this. I actually went first class once in my life. I was traveling to Peru with my then girlfriend and our dog, and they let us sit in first class. And it was like the first leg of the trip, so it was like an hour and something. And then the next leg we were in economy for 11 hours or whatever. I was like, God, what the? Anyway, sorry. Nothing to do with anything. There was so much room. I'm sorry. All right.
You probably went to a long bus ride from there, right?
Say again?
And then from there, you probably went on a long bus ride.
Oh, no, actually, no. Thankfully, we went to Lima, so we didn't have to go. We did go to Machu Picchu. We did take a bus. We did take a combi, all kinds of travel options. But yeah, that's a whole other thing. Don't worry. Get to Machu Picchu, kids. It's good. I'm just trying to show off that I've been places, man. Is everybody cool with this one? So why is it? Because of the fact that it's describing a population. That's why. Describing a population. Some people say it's a statistic because it's a percentage. That doesn't make any sense. A parameter and a statistic are fundamentally the same thing. The difference between them is what group are they describing? That's all. So 71.3% could have been either one. It's describing a population, so it's a parameter. Okay, I like it. Describing pop. All right, so this guy, this is the way I ask this question. I ask it, I give you all the options, so you don't have to kind of like remember all the names. You could just see them. You have to remember what they mean as you see them. So what do you think 3A is? Somebody else who hasn't spoken up yet. Does that have a method to it? What would 3A be?
Random.
Yeah, there's no real method to it. It's just a random. And to be honest, you can even say simple random. But yeah, from my options I gave you, that's just random. There's no extra method on top of that, right? So the problem, the people get a mistake, like on part B, I'll have people tell me it's random, and it is, but it's more than that. You've got to tell me, be as specific as you can. So yes, this is random, but what method specifically on top of that? All patients from 4 selected hospitals.
Cluster.
Cluster. So all from some. That's the, oh, I just noticed this. Well, anyway, it doesn't matter, Jeff. 3, I'm not even going to say. So cluster, because it's all from some. What about this one? Somebody else.
Stratified.
Yes, stratified. Why?
Some from all.
Exactly. 11. Stratified is some from all. And of course, part D is very, very straightforward. It's obviously going to be what? Or is it obvious? I don't know.
Matic?
Yes, every 8 minutes, systematic, because it's every nth. In this case, specifically every 8th minute. Not bad, right? So we got kind of technical describing them and so forth, but this is the kind of question I'm going to ask. You just have to be able to differentiate between the styles, between the methods. I like it. Am I recording? Yes. Okay. Any questions from that? That's basically everything we've done so far in 5A. Okay, so now we got a couple of things left to look at. I'm going to stop sharing. Stop. There we go. Man, my laptop thing is trying to do its best. All right, let me see. Blah, 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 blah. Okay. Oh, let me do this. I'm going to show you guys this. Why not? This will lead us into this discussion. Where did it go? Okay, there it is. All right. Oh boy. Okay. Let's see. This is going to be interesting. Let's see. So here's a study. Oh, let me go up to the top. Here we go. Get up there. Community use of face masks and COVID-19 evidence. Blah 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 blah. Okay. So I think I said earlier, I've talked to people that believe COVID's a hoax. They believe that the government wants us to wear face masks just to show that they can make us do stuff. That's the level of logic use that we're at, folks. Hopefully everybody in this class, I don't even give a shit what your opinion is. That's wrong. It's just wrong. I have no qualms saying that. And if you disagree with me, you're wrong. So just live with it. Or don't go outside then if you can't follow simple mandates. If a piece of cloth in your face makes you feel like you're a sheep, which I love, then maybe don't go anywhere. Maybe stop. All right, enough of that. So this study, what they do with this study, let me ask you this. If they were going to do a face mask study, would it be ethical to have like a group of people not wear face masks and go somewhere and a group of people that do wear face masks? Would it be ethical to do that?
No.
No, because there was evidence before this that face masks probably would help. So that would not be ethical. Would it be ethical to have a group of people not get any water for a day and then another group get water whenever they wanted to? No. So when you have a situation where you want to see the differences in things, like if you don't wear a face mask versus you do, you cannot do an experiment. You must do what's called an observational study, which means you just go find groups of people that are in a situation naturally. So you didn't force people to not wear a mask. They just don't. In this case, now most good statistical analysis journal papers. So let's see what they talk about. They talk about the idea behind what they're going to do. That's what the abstract is. Kind of sets up the idea. Then they get into, this one gets into the data and the methods, how they collected their data. They even get into, let me see, is this the one that has, here's the statistical analyses. Here we go, look at this. Really good articles will discuss limitations. So they're not able to measure face cover use, but the next best thing was to measure mandates. So we all know that some states had certain mandates and other states didn't, right? You guys with me on this so far? No? Are you guys aware of that? All right. Can Joe Biden force everybody in the United States to wear a face mask?
No.
No. But he did do something. Does anyone know what he did? One of his first day, what do you call it? Executive order.
You passed an executive order asking Americans to do a 100-day mask challenge.
100-day mask challenge, but so that was just asking if they could. He did something specifically. He can control what happens on federal land, in federal buildings. So he said, if you want to go on federal land in federal buildings, you must wear a face mask. That's where he has total control. And of course, the idea of the United States is states have certain rights that aren't given to the federal government. So anyway, enough of that. Again, I mean, I want to make this into a government or a history class, because then you would probably all fail because I only know so much. What else did I want to show you here? Yeah, so this is kind of like the thing where so one thing I wanted to point out, that the next idea we had to discuss was the difference between observational studies and experimental studies. Does everybody get that idea now from what we just discussed? When do you do an observational study? Well, not only this, but you definitely would do an observational if it would not be ethical to have like a control group and a group getting treatment, right? Now, if you're testing efficacy of different treatments and there's initially no idea which one's going to be better, then you could do control groups and such, right? The ethics are on your side. But very often you hear stuff like, I can't remember the exact wording, but they'll stop a study and just say, use this shit, because they notice it's working really well in their studies, and like, let's use this shit on the people that would die otherwise, right? What's one drug? Well, I don't know. Again, I don't want to get too much into politics, but hydroxychloroquine has not been proven to be effective. There are some studies that seem to say that maybe it is, but it has not been shown to be effective, regardless of what inconsequential people believe. They're inconsequential now, thankfully. Jeff, more opinions. All right, and then there's all kinds of cool shit. So this is why I'm kind of sad that you guys might never take a full-blown stats class, because there's so much cool shit. I mean, look at this. Look at this thing. Isn't that cool looking cool? It sort of looks like TIE fighters. I always love this kind of graph. Some TIE fighters have a longer wingspan. Does anyone not know what a TIE fighter is? It's not somebody from Thailand that fights. It's not somebody who doesn't like to wear ties. All right. No? Okay. It's a Star Wars thing. Okay. Blah, 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 blah. And they have discussion. Okay, that's enough of that. Something else I want to show you. Let's see. Yeah. No. Anyway, I don't care. So last job, Trump job approval, 34%. So this is a website called Gallup. Has anybody ever heard of the website Gallup.com? Gallup.com? No? It's one of my favorite websites. They are a statistical analysis group. They take surveys of people and post results. So the great thing is they'll go through and they'll discuss what they discovered. The 34% job approval rating is from a January 4th through 15 poll, blah, 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 blah. They give little graphs over time. But if you go to the very bottom, they give like comparisons amongst different presidents. If you go to the very bottom, there it is. Survey methods. They tell you how many people they spoke to, how they talk to them. This is telephone interviews, which has a problem with it, right? What's wrong with telephone interviews? Can anybody tell me anything wrong with telephone?
You probably don't know who you're talking to, the information of the person you're talking to. I don't know if you have to talk to a person within a certain age range.
So that pretty much sums up, you could just say the person might lie.
Yeah, it could be one of the teen kids.
Yep, gotcha.
Who love to, do prank calls.
Gotcha. Anybody else? Is there a different problem with doing telephone interviews?
Only some people pick up the phone.
Okay, good. And if they do pick up the phone, they could very quickly say, screw you. All right, anybody else? Does everybody have a telephone?
No.
No. If you think everybody has a telephone, enjoy your privilege. No, so there are a lot of people in the United States that don't have a phone, they don't have internet access. There are quite a decent number of those people, so they would never be able to be in there. So one thing that's left out of this that Gallup does discuss somewhere else is the methods they use to account for every problem you guys have just brought up. And of course, any survey, people could lie on it, right? So that's one of the first things you learn when you take a statistical survey methods course is how to account for the possibility of lying. But we're obviously not in a statistical survey methods course, so I'm not going to go deep into all that stuff. Something else I want to point out. Read through, look at what the shit does this mean? For results based on the total sample of national adults, the margin of sampling error is plus or minus 4 percentage points at the 95% confidence level. Okay. And this is something we're actually going to talk about. This is one of our next things we got to talk about is this. Does anyone have any feel for what that might mean? So like up here, when they say, when they say 34% approve, 46% approve, how does that come into play? We actually talked about this a little bit before.
Wasn't
this
the thing that you said a few classes ago, where it was like people would say that so many people would vote for this person before voting would happen, plus or minus?
Yes, so this is the same thing. So when they say 34% approve, it could be anywhere from 30 to 38, right? Because it's plus or minus 4 percentage points. Now, what's really interesting, so that's the plus or minus 4. That's pretty straightforward. What the shit is this? What the shit? All right, so let's talk about, is everybody okay so far? So like John, I think it was John just said, we did discuss this plus or minus thing before. Not a big deal. We've talked about how to pick a sample today. We talked about some of the problems this has, and they do have to account for those problems. And if this was like a full statistical analysis paper, they would have to describe how they overcame the problems of not everybody has a phone and all that kind of stuff. You guys kind of with me? And there are ways to account for that, believe it or not. So the only thing that's not understood for us right now is this thing. All right, so let me stop sharing. I want to talk about that just a little bit. The book talks about it a little bit. What that means. All right, you can do it, Jeff. So Gallup took a sample of 1,023 adults, right? And they found somewhere between 30 and 38%. So let me ask you, before they even do a survey, before they even talk to anybody, doesn't there exist a percentage of Americans who approve of the job Trump was doing in the last few weeks of his presidency? Right? You guys with me? Doesn't that exist? You guys, whatever it is, it exists. All right. So that's somewhere. That's something that's, I don't know what it is. So when they go take a sample of people and they get from 30% to 38%, there's a chance that the actual percentage is in that interval they made. What's the chances it's in there? 95%. So if some other group, if 100 groups, 100 different groups took their own samples, would they all get the same 1,023 people if they randomly picked 1,023 Americans or adults in this case? No, I would put money on they're all different samples, right? If they truly randomly picked it from all over America, they all got different samples. So wouldn't they all get different? They would all get different little intervals like this, right? They would get different intervals. What percentage of those intervals would not contain the real percent? 5% wouldn't. So 95%. So 95 of these would actually contain the real answer. And only 5 of them wouldn't. That is what that means. because the only way to be 100% confident would be to go negative infinity to infinity, which is not useful, right? In this case, it would be 0% to 100%. If somebody said, I did a study, and I think somewhere between 0 and 100% approved, it's like, get out of my face. Okay, I don't want to get too deep into that because we're not going to make a big, huge deal out of it. But anytime you see statistical analysis, they do have to describe what level of confidence are they at. So the results on this Gallup page, there's a 5% chance that they're wrong. And that is one reason why people hate statistics. But to me, it's like why I love it. It's the most honest math. It says, okay, here's the answer, maybe. I mean, and that's life. Shit, that is life. So statistics is math doing the best it can with messy life. I love statistics. I think you can pick up on that. All right. Enough of that, Jeff. You're not going to convert them to statisticians, so I'll stop. Okay. Get out of there. Blah, blah, blah. Okay. I'm trying to remember what I want to do next. Yeah. All right.
A lot of this is going to be on the test, right? This part here.
Say,
Because
do it again, sorry.
So the 30 to 30%, that's what I want to make sure I understand 100%. You say here there was a sample of 30% to 30 to 38%.
All right, so the Gallup people, they think that the interval 30% to 38% contains the real percentage,
okay.
right?
Okay.
And why did they not find the real percent? Because they only talked to 1,000 people.
Okay.
Right.
Okay.
And 1,000 people is a really good sample size, even though how many Americans are there? How many American adults? Probably like 200 something million, right? You guys with me out there? And 1,000 is actually a good sample if you pick it randomly. And Gallup has a decent track record of picking random samples. Okay, maybe. If another group took another group of 1,000 people, they would get a different confidence interval. They would get a different, maybe theirs would be from 29 to 35% or something. Okay.
Can I ask a question?
Sure.
Where do they get the plus or minus 4% from?
Okay. I talked a little bit about this. Look, I'm gonna completely answer your question, and you're gonna wish I didn't. You ready? You're like, oh God, what have I done? I'm gonna completely answer your question. I love this. Here is the formula for figuring out 30% to 38%. You ready? Here it is. It's the percentage, give or take, some funky ass z-score times the square root of 2 percentages divided by now. All right. I don't even know if you can really see that. Can you see that? Shit, I chose the wrong color. All right, now it looks like you're blurry. Okay. None of this shit matters. I mean, if you took statistics, so P is a percentage that do something. So Q is a percentage that don't do that something. Z is a special statistical kind of distance thing. N is the number in your sample. Now watch. Nikki, you asked for it, buddy. So you don't have to know shit about this formula. You don't have to know shit about it. Screw this shit. The important thing is right there. If I want to make this piece small, so this would be like the plus or minus 4%. You get what I'm saying? So that's the plus or minus. If you do all this work, if you just plug in all the stuff, you'll get about 4. Let me stop for a minute. Whatever this shit is, whatever these things are, you'll get 4. How would I make that smaller? I would make n bigger because I'm dividing by n. Do you see that? So if I take a larger sample, my error gets smaller. That I don't need a math equation to tell me that, but the math equation better capture that idea or else it's bullshit. So we already knew the bigger the sample, the better I see. And so the math equation better capture that, and it does. So I don't put that up there to scare you. I don't put that up there to whatever. I just want to show you that is the actual equation to figure out the plus or minus 4.
So if it's always 1,000, then it's always going to be the plus or minus 4.
Yeah, and this number would change if you want to be 95% confident. If you want to be 98% confident, this would get a little bigger.
Okay.
And then these are based on the percentage from your sample. That's why it's got a little hat on it. It's kind of neat. If it's got a little hat on it, that means it came from a sample. All right. And these are all the things you could get if you took a statistics class, everybody. But no, that's enough. Sorry. So again, that formula, how well do you have to know it? Not at all. But I just want to show you there is an actual place, a mathematical place that number comes from. It isn't just like, what do you think about this one? Oh, plus or minus 5. I'm not really sure. Okay. No, it comes from a formula. And if I want to make the error smaller, I can. I just pick a bigger sample. All right, enough of that. I love that question. Hopefully I didn't go too overboard with that. Okay. All right, let me see. Where was I? Oh, yeah. So let's close the door in section 5A. One last thing to talk about. Has anybody heard recently anything about a statistical method called blinding? Blinding? Not, not she blinded me with science. No. Blinding. So single blinding. So let's say you go into a study. Let's say you're one of the people that went for the COVID vaccine study. You with me? There were people that signed up to get the vaccine so they can test results. When they did that study, there were at least 2 groups, probably 3, that they worked with. What were the groups? Whenever you do a study of something like a drug or a vaccine, what are the groups that they work with? I know you guys know. One group gets what?
Placebo.
Sure. One group gets a fake thing, right? Placebo. And then, of course, one group gets
the actual one.
The actual thing. And then the third group, which they wouldn't have created, it would have been more observational, is the people that don't get the vaccine, which is whoever's not in the study. It would just be observational. It's just what they've seen. Is everybody with me so far? So I know you guys fundamentally know this. I know most of you know the words control group. Most of you know the word placebo. Anybody never heard of the word placebo before? It's not Placido Domingo. It's placebo. Okay. All right. Everybody's heard of that. Everybody heard of the placebo effect? What's the placebo effect?
Psychological. Is it a psychological reaction where you the real thing, like on a show from way back, if kids haven't even heard about it, where you're thinking that you're taking an actual medication, so you start feeling those symptoms.
You start feeling better. So that's like your own body's capability to do something, right? So the placebo effect is an actual real, it's not just psychological. It's actually, in some cases, it's a real reaction of the body. So it's kind of like the mind-body connection and all that kind of shit. I'm not going to get all, I'm not a spiritual healer dude, but there's an actual connection. Anyway, so they want to make sure that anything they see from the actual treatment isn't just that placebo effect. So they have to compare. All right, I forgot what my point was. Oh yeah. So in a single blind study, Let's get rid of that funky formula. In a single blind study, thankfully, they don't poke anybody in the eye for this. Single blind just means the participants don't know which group they're in. Which, of course, is kind of like, for most things, it's a bare minimum. If you know you're not getting the real drug, is there more or less of a chance that the placebo effect will happen? All right, I don't know what to do.
Less.
Wouldn't it be less?
Yeah, there's less of a chance because you know you're not getting the real drug. If you believe there's a chance you're getting the real drug, that's when the placebo effect might happen. And I have to test against that. So I don't want my people that are in the study to actually know which group they're in. That's single blind. So what do you think double blind would be?
They don't even know they're in a study.
No. That's called unethical. Now, double blind. Go ahead, Heather. You got it?
The testers and the participants both don't know.
Beautiful. Now, why the shit? Now, number one, you could think, how the hell would they do that? So this would be like the researchers also don't know. Which group they're in. Which group that the participants are in. Now you could say to yourself, well, how the hell would they? All right, they get results, but they don't even know. Just because the researchers don't know doesn't mean that a computer doesn't know, right? So while the study is happening, the researchers have no idea if they're giving the real vaccine or not, or the real medication or not, depending on what kind of study it is.
For less bias.
Exactly. If the researcher knew and they kind of really want this to work, they might self-select results. They might, who knows, subconsciously, not even to be, what's a good word there? I don't know. Not even to be manipulative of the data, but just subconsciously, you could start doing things as a researcher. So that's why a lot of people talk about the double-blind experiment being like the best study, and normally it is. There are some cases where single-blind is perfectly fine, a lot of cases, but double-blind is the ultimate kind of like place you want to get to. That doesn't mean single-blind
is only. Single blind is where only the participant doesn't know what group they're in, and double blind is where the participant and the researcher do not know what group they're in.
Exactly. Right. So for example, just to give you a logistical way you could do this, you could have vials and they are all put together and kind of like filled by like an assembly line computer. So the computer puts a little, has a machine put a little barcode on each. So as I put it into people's arms, I have no idea. It doesn't say vaccine or, or water or something, well, you don't want to put water, but it doesn't say that. It just has a little barcode. So after the study is completed, they can then scan the vials they gave to each person, and then they know. So there's no way that during the study they could bias anything. So that's how you actually logistically pull off a double-blind situation. Because when you first hear about it, you're like, if nobody knows, how the shit they're going to do anything? Well, it's not like nobody knows. Normally, it's a computer knows. Okay. You're like, well, if the computer becomes sentient, no, that's a whole other thing, guys. That's a whole other thing. Okay. What time is it? Okay, we got some time. Good. That pretty much closes the door on section 5A. Now we're going to talk about section 5B. And what 5B does, I sort of got into this a little bit when we looked at the study. So let me put this up here. So we're still talking about statistics. 5B, we sort of seen lists like this earlier. What was it? I forgot. It's gone. But this one is a list of what to consider when you are looking at a statistical analysis, right? When you're looking at one of these studies, like the ones I showed you earlier. The first one is pretty much makes sense. It's what's the big picture? What are the goals of the study? What's the population in question? What type of study is it? Observational or experiment? Let me stop for a minute. That kind of makes sense. And that's why that is kind of covered for most analyses, either in the first paragraph or like Gallup did, they have something at the end where you can go look at their methods. But normally in a paper, so the very first thing they address is this. What's the goals? Who are we looking at? How did we pick our sample? All this kind of stuff. Okay, now obviously, the next big thing to look at is the source. So, oh yeah, that's right. Remember it was about analyzing news stories. I think earlier we had something like this. And this was in there also. So what this means is, where's the money coming from, right? Or who called for the study? So it'd be funding for the study. You can do it, Jeff. Who called for the study? So if there's a study showing you that chocolate actually makes your heart health better, and it was funded by the Mars company, I don't think we should trust that. It could be a completely fine study, but you screwed yourself in the beginning. I can't trust something that was funded by a Mars candy bar company about how chocolate is good for you. I can't trust that. Okay, maybe. And of course, the next thing is what we know has to come in is, are there any possible sources of bias? And there's two main types of biases. There's one called selection bias. And this one we talked about. This one, you can immediately see this is kind of like the convenience sample, right? If the researcher selects the sample specifically, like it's people he knows are healthy or people that she has worked with before or whatever, right? If the researcher hand selects the sample that they're going to work with, I cannot trust the results. That would be a really good source for bias. So that's selection bias, is if the researcher hand selects people based on something. And there's also something, I forgot the name of it now. All right. I don't call it this. The second one, they call it participation bias. I call this voluntary selection. What do I even call it? Okay, voluntary response. How did I forget what my phrase was? So this would be, I think somebody else brought this up before, like if you don't even answer the phone, or if you answer the phone and say, I don't want to be a part of this, or if somebody mails out surveys and only 5% return them. Why did they return them? They probably feel strongly about whatever it is, and they're probably going to skew the results. That's what bias means. Is there any chance your results are skewed because of self-selection? So this one is, they're both some kind of selection, isn't it? This is the researcher picks people for something, and this is individual participants pick themselves because of something. Okay, I like it. So there was even in math, we have problems with people understanding data. There was certain kind of math courses where they were saying, wow, look, everybody's doing great in these math courses. And the students self-selected to go into these courses. So these were motivated students And it was a new course, so they had their best teachers teaching them. So can I really compare the results of those kind of courses to regular courses? Not really. I got to take it with a grain of salt. It's not saying it's bullshit. It's not. It's just saying I can't trust it because there are sources of bias in there. Okay, maybe. Maybe. All right. I need some liquid. So then the next thing you gotta look at is how do they define and measure their variables. So in this case, variable could be the amount of time somebody lives after they get a treatment or something. So you have to, how do they define the variables they're studying, and how do they measure those? So they've got to discuss that. And we all know the word variable from algebra, but what does variable mean in statistics? It basically means the same thing, but something I like to relate it to is the variable in statistics is related to the question you would ask. So if I wanted to know what percentage of people prefer Star Wars to Star Trek, right? The variable would be their preference. The variable would be Star Wars, Star Trek. It's related to the question that I ask. That's what the variable is. The answers I get, we call data. That's not surprising. Okay. How you guys doing out there? All right. This is a very exciting part of this class, I know. Watching me put definitions on a board. All right. We got some more. Here comes some more. Oh, joy. The fifth one is also about variables, but here's a freaky little definition for you. There's something called confounding variables. Has anyone ever watched a show called Mythbusters? I don't know if I've asked this question before. Anybody? Nikki's watched it. Anybody
Yes.
else? Mythbusters, yes. If you've watched it, I don't know if you remember, they will very often say something like, we need to control for variables. We need to control for variables. So when I'm doing a study, if I want to know the effect that this drug has on people, what else could change how people react to drugs? Are there any other variables besides the drug itself?
Yes.
Shit, yeah. Right? Their age, their health, their diet, their, I don't know, their genetic makeup. Holy shit. I mean, there's so many variables that could confound the results I get. They could kind of get in the way. They could affect what I see. So I'm thinking it's my drug that's making something happen, when actually I just happen to pick a bunch of people that are on the keto diet or something. I don't know why that came to mind. You guys with me out there? And maybe it was that made things happen. So I need to identify the other things that might affect what I'm trying to measure. And that is really difficult sometimes. There are whole studies that were done that were later disproven because we eventually found out there was some thing they didn't even know to think to look for. I mean, oh, they all happen to be this, or a large number of them were this. And went, oh, shit. Does everybody get that? That's a weird word, confounding variables. Let me see. How did I define it? A variable not considered that can influence relation. Oh, I like it. This is my own definition. It's a variable not considered. Right? So it's not even in your brain when you're doing this. That could affect the relationship between studied variables. So you're studying the effect of this medication on somebody's health, and there are all these other variables that you have to kind of account for. All right. I don't know how much of my audience I've lost. I feel like a YouTuber. Everybody's logging out. Couple more things. Couple more things. Here's a good one. This is kind of freaky. The wording of surveys and the setting they are given it. Listen, guys. We just had an election. Does anyone know? Let me just say this. There is a huge push for every election to be the first one listed on the ballot, because there's a natural bump that the person or thing or proposition that's listed first, the first option, gets a natural bump, because there are people that just go in and go, all right, first. Okay, I'm done. So there is a statistically analyzed and verified bump that you get if your name is first in the list of candidates. Do you guys know that? Anybody ever heard of that? So there is a whole process in each state about who gets to be listed first, which kind of makes sense. No, maybe, never. Whatever, Jeff. You're weird. Okay. All right. So that's what this kind of means. And the wording too. In fact, even sometimes just the order that you ask questions in. So like I said, there's you could take a whole couple years worth of courses just on how to construct a good survey. There's so much in there. It's insane. All right, we only got 2 more on this list. All right, here we go. This one is about how are the results presented. And this is where you can, be misleading, right? Like you have a bad scale. Is the scale good on graphs? And whatever else, blah, blah, blah. This is where you can be misleading with your results. You give, so, I mean, for example, if I really wanted to make the difference between 2 things seem big, I could just not start at 0. So maybe I start at 51, 52, 53, 54, 55. Doesn't this makes it look like, whoa, look at the difference between those 2. Everybody rise up and be angry. When actually, if you drew it starting at 0, that would be what the difference looks like. So, I mean, that's a very simple example of how you can present the data accurately, but in a misleading way. So this is accurate, but it's misleading. It didn't start at 0, so it overstates the difference in heights. This is the one I see all the time. Oh my God. We're so easily manipulatable. Manipulatable. So easily swayed. There we go. Okay. And then finally, the last one, consider the conclusions. So in any statistical study, they should discuss the results, the implications of the results, further studies that might need to be done. So when you see a study reported on in the news, they obviously take the most sensational parts of it, right? Or they take it too far, or they say as if it's true. And if you look at the study, it's like, we're not sure about this. We're gonna have to do some more study. Like, whoa, news. You told me I should eat 18 eggs in a day. And they're saying, well, maybe not. So yeah, you never know. Don't eat 18 eggs in a day, kids. All right, now I'm tired from that. Jeez, Whew. How you guys doing? You all right? That was really boring, but hopefully, I mean, I think all of those should make sense to you. And they really do a good job in the textbook about breaking those ideas out. They have the whole list in the book, and then they kind of go through each thing like I just did. Blah, blah, blah. Was there anything else I missed here? I don't think so. Yeah, they do a decent job of talking about confidence intervals in 5A. What we just did was 5B.
Professor,
Yes.
I have a very simple question. I'm going to try to remember to ask it. You mentioned that, okay, observational studies and the others are experimental studies. Could you just, experimental are the statistics, the surveys.
So experimental is where we actually apply a treatment to some of our sample. That's experimental, right? And the treatment could be putting a mask on somebody, shooting them up with a drug, yelling at them, whatever. We actually cause that. We actually do it to see the results. Observational is we go find where that happened naturally, right? So if we're like, what would happen to you if you ate 28 ding dongs every day? You know,
Yeah.
You guys know ding dong or Twinkies or whatever. And like, well, that would be probably unethical to shove that in somebody's mouth. So just go ask people if they did. And they find some guys eating 28 ding dongs every day. Wow, you're not looking too good there, buddy. So then they could do a study like that. And they, you know, it's a very silly example, but does that make sense?
Yeah.
The most immediate, obvious thing, this is not covering every possibility, but you would do an observational study if it's unethical to apply whatever it is you're trying to see the effect of. You just go see if it's already happened and then kind of do it. So there are problems with that, but it's the best we can do. We don't want to shove 28 ding dongs down somebody's throat. You know, or there's other things we don't want to do. Does that make sense between those two?
Yeah. Thank you.
Okay. And I just want to show you guys this. Here's this list of all these things we just went over. This is page 309. They go through the list and then they go through each one and they give little examples. And they, you know, if you're not looking at these examples, I don't quite understand you. Examples are awesome. They'll help you with the homework. And then let's see, 5D. I do skip 5C. Why? I don't know. I just did. What do you want from me? 5D gets into this kind of thing. And I do want to show you, I mean, you get some very interesting looking graphs that people have no idea how to read. Right? So, I mean, this one isn't too horrible, I would hope. What's the immediate thing that you want to get from this graph here? What is it they are trying to show?
Get a degree and you'll make more money.
That's one thing. Yeah, you can immediately see that if you get a degree, you make more money. What's the other thing? What do the little different color bars mean?
Men versus women.
Income.
Yes. So, of course, you know, this is where, I mean, look at the difference here between doctoral degree and professional degree for women versus men, right? So we all know there's a disparity in pay between the sexes. So that's basically what this is saying. All right, but you're also right. The higher the degree you get, the more money you should make on average. So not every person would have that happen necessarily. Here's unemployment rates. Now, what's funny about this, not funny, do you see what year this stops in? If I kept going to 2021, what would happen to this picture? I mean, this would get squashed because in 2020, it would just skyrocket. It's insane, right? But what else does this show? So this shows unemployment rates. These lines all have the same general shape because, of course, here was the recession, right? Good old George Bush. Bit of a recession there. But then the different lines talk about what degree that they have. So again, these together, these kind of show you higher degree is good, right? And also here, if you can, be a dude if you can. Sorry, it's just the way it is. I'm sorry. And I don't want it to be that way, but it's just the way it is. Let me show you this. Have you guys, I don't know where you guys go for information about the pandemic. But one of the places I really like to go to keep up to date, it's called Worldometer, and it's got some funky ads on it, but oh well. Has anybody ever seen this website before, Worldometer? And what they do is they show you some statistics about pure numbers. This is in the US, by the way. Cases, deaths, recovered, some percentage stuff, right? So far we have a 3% case fatality rate. So amongst all the cases that are closed, 3% resulted in death. 97% resulted in recovery. So again, the COVID denier people say, well, if I have a 97% chance of surviving, why would I worry about it? Well, because 3% dying means an insane number of people. That would mean 9 million something people dying in the US. All right, sorry. Again, I'm preaching a little bit. Let me refresh this a bit. So it gives you straight up, look at all these numbers. Oh, look at all this data. It just makes me so happy when I look at all these numbers. Not happy because of the results. I'm sorry. Don't get me wrong. That was not the best way to describe that. These are terrible, terrible numbers. But I love that I get all these numbers. I can analyze it however I want to myself. And then down here, they give you graphs. Now, let me throw this in here. What is that blue line? So right now, the blue line is at 197.50. Yeah, go ahead.
It defines the number to the left, doesn't it?
What it is on January 20th, the average number of cases for that week leading up to the 20th was 197,054. So per day, there was an average of 197,054 new cases. So you can kind of see where the per day average peaks here. So this is a little bit more useful than just the pure number of cases per day. And then you got this crazy dude. Because that's 3-day average, and that's going to be a little more insane because it's affected by weekends and stuff when reporting kind of falls down. Okay, enough of that. So that whole section is about ways of presenting data visually. And there's a little section in there about what we talked about a second ago, having a scale that misleads people, stuff like that. So there's ways to mislead people with graphical representations in there. Okay, I'm done. I think I've talked too much today. That's plenty. So if you have any questions, you can hang out. We can talk. Otherwise, you are free to go. And hopefully this weekend I'll catch up with grading. We'll see what happens. I'll definitely grade the stuff that's related to the quiz on Monday, for sure. Everybody good?
So
You guys are?
this quiz is on Monday for this chapter.
Not this
wait,
chapter.
we have chapter 4 still.
Yeah, the quiz on Monday is on chapter 4. The reason I do that is because there should be a higher chance that more people are done with chapter 4 homework by Monday.
And then we have this test on Tuesday.
Yes, the next day we have a test on this. Yeah, the quiz on this. Yeah.
Okay, sounds good. Thank you
Can't
very much,
believe
Professor. Have a good day. Bye, everybody.
Next week is our last week. That's crazy. And then I might never see some of you guys again. Well, I'll be right. All right, guys, I'm out of here. I don't see anybody with questions. Take care.
Bye.